All right, Algebra 2. Let's finish out Chapter 8. All right, shall we? Let's get into today's notes. We're doing Section 8 today. As you see here, we are skipping 8.7. Don't need to do it. It's one of those sections where you're doing transformations, and we've done about 50 of those. So I think we're good. All right, we're skipping 8.7. Let's jump into 8.8, all about solving radical equations and inequalities. I'll give you the heads up. The one inequality problem that we're going to solve, we're going to use the calculator. We're going to need the graphing function on that. We're going to do that one in class. Okay, so make sure that you guys, as normal, remind Mr. A. We will do that last one in class together so that we're all on the same page. All the other problems, it's going to be pretty easy. All right, very straightforward. Everything you see there on this page, everything that's highlighted, you have to have down. If you want to copy it all, yes, copy it all. But the minimum there is the highlighted right to the point stuff. That does include these example problems here. I want you to copy those down. It's just going to give you more help. All right, more visuals to get you through the section and get you ready for your test. All right, so key thing, start by isolating the radical. All right, and what I mean by that is isolating the radical is get everything that's around it away. So if there's a plus or a minus something, do that. If you need to multiply or divide something, you're going to do that. But as this says, you're going to multiply or divide first, then you're going to add or subtract second. Then that should leave you with just the radical. All right, it might be a square root, it might be a cube root, kind of just depends on what they're throwing at you. All right, this is a little reminder. To get rid of the square root, you got to square both sides. To get rid of a cube root, you have to cube both sides. And never forget, of course, do it to one, do it to both. All right, and then this last part, the radical inequalities, as I already said, we're going to use the graphing calculator. I'll show you in class. And there's this one little extra step, unfortunately, right here. Check your answers because you might get these guys called extraneous solutions. And an extraneous solution is a not possible answer. So you could do all the steps right, and you could get two answers. Let's say you got 3 and 2 as your answers. Then you go back and check your work by taking those answers one at a time, plugging them back into the original equation. And lo and behold, you'll find that one of them makes it a not possible or a no solution situation. That would be because it is an extraneous solution. Then you don't include that answer in your final answer. So let's say you plug 2 and 3 back in, and it turns out that 3 doesn't work, then only 2 would be your answer. All right, and 3 is extraneous, and you would not include that one. Okay? All right, copy these 2 examples down here. Follow the work that's presented. Let's do some examples of our own. Okay? Okay. Here we go. Example problems. First one here. As I said, you have to isolate the radical. And in doing so, that means we either multiply or divide first or add or subtract. And what we're looking at here is this that can be eliminated. How do we get rid of this 4 right here? We're going to have to subtract the 4 on both sides. Okay, so that's going to allow these guys to cross out. You're going to be left with the square root x minus 1 now equals 1. And now it gets to the point of how do you get rid of the square root? The opposite of a square root is squaring both sides. So you have to square both sides. The square root and the square will cross each other out. 1 squared is simply 1. Now this is all you have left. X minus 1 equals 1. X equals 2. There you go. So there's the steps with a little intro type problem where we had to use subtraction, then isolate the radical, square it, simplify it. All right, let's take a look at this one here, where in this case, you don't have any multiplication, division, add, subtract, but you have a cube root. So how do we get rid of a cube root? You cube it, all right? And that goes for both sides. So we're going to cube both sides. A cube root will cross out with a cube, leaving you with just what was underneath, 3x minus 4. 2 to the third power, that's going to give us 8. Okay, and now we simply go through basic algebra here. All right, let's add 4. That crosses out, add 4. 3x equals 12. X equals 4. All right, so just go through the basic steps there. The key thing to notice is this first thing. We had to cube both sides because we had to eliminate the cube root. All right, and again, what you do to one side, you do to the other. Okay, let's move on. Example problem number 3 here. This 6 is on the outside being multiplied into this radical here. So how do you get rid of that 6? By doing the opposite, meaning you will have to divide both sides by 6 to eliminate the 6 here. And then 42 and 6 work out perfectly. So we have a square root x plus 10 equals 7. Now how do you get rid of the square root? By squaring both sides. They eliminate each other. X plus 10 drops down. 7 squared is 49. And then all you got to do here, take away the 10. And x equals 39. Okay, there's all the steps we did for number 3. All right, let's take a look at number 4 here. A little bit more involved. Okay, not too much. Because this is an exception, because we have radicals on both sides, that changes our order here a little bit. Again, because we have radicals on both sides, we have to actually get rid of the radicals first instead of isolating the radical. Because we have 2, if we were to divide both sides by 2, that doesn't eliminate that 2. All right, it eliminates this 2, but incorporates a new one on that side. So that doesn't actually help us. Both sides have a radical. Eliminate that radical first. Now this becomes your priority. And how do we do that? Well, it's a cube root, so we will be cubing both sides, except this side, we have to put in parentheses and cube it because of this 2 right here. That 2 is incorporated into everything on this side. You can't just separate this 2 from the cube root. They're connected. And in return, that means that when we do the cube, we will be cubing that number 2. The cube will eliminate that, but the cube will go to that 2, and that means taking 2 to the third power. All right, so let's keep going. These guys cross each other out. X plus 6 drops down. That 2 is going to be brought to the third power. Don't forget that. All right, and when we do that, that's going to create 8. Then crossing that out, we're now going to put that x minus 1 in a set of parentheses because it was all underneath that radical or that cube root. Okay, now we're going to have to distribute the 8 into the parentheses here. X plus 6 drops down. 8x minus 8. And now just go through your normal algebra steps and solve. All right, so I'm going to go ahead and take that minus 8, bring it over. I'm going to take that x and bring it over here. And let's simplify that. So we're going to get 14 on this side equals 7x on that side. And then let's go ahead and divide and x will equal 2. All right. All right. So that's what we're getting there. Okay, good. Let's go ahead and move down. Example problem number 5. All right. So again, this goes into that category of we've already isolated the radical, so we just need to get rid of the radical. But what you're going to notice is that we have a little bit more going on that side. Okay, it's not just one term. We're dealing with 2 terms, and these terms are connected by a plus sign. So that means that whatever we do, we have to do it to the entire negative x plus 4. So let's do that. How do you get rid of a square root? You square it. But that means we're taking this whole entire expression and squaring it, meaning we're going to take negative x plus 4, doing that twice. Okay, so the negative 9x plus 28, that's all good. That just drops straight down because these guys cross each other out. But this, on the other hand, right here, basically means we have to write that twice and then FOIL it. All right, so that's the same thing as writing it twice. Negative x plus 4, negative x plus 4, and then double distributive property into those parentheses right there. So now this entire expression right here, this entire expression is going to simplify down here. A negative x times a negative x is going to actually now just make x squared. Negative x and 4, negative 4x. 4 and negative x, again, negative 4x. 4 and 4, positive 16. Drop that down again, simplify x squared minus 8x plus 16 equals, and then we're going to take this and put that right there, negative 9x plus 28. All right, let's start to get everything on the same side. We're then going to have a trinomial, and we'll see if it factors. So we're going to take both of these guys and move them over. And then once we move them over, let's rewrite what that creates. Okay, so you're going to have a negative 8x. We're going to move a negative 9x over. When you move that negative 9x over, it's going to be a positive 9x. All right, x squared drops down, nothing to go with. Negative 8, positive 9, just make a plus x, right? Negative 8 plus 9, positive 1. Now that's a 16, but when we move this 28 over, it's going to be a negative 28. So you're looking at a 16 minus 28, giving you a negative 12. This is now the trinomial that we're dealing with from everything at the beginning of the problem. Now this trinomial, I believe, will factor. All right, double set of parentheses, x plus minus 4 and 3 work out perfectly. Okay, now solve these parentheses, giving you negative 4, positive 3. All right, that's what x equals, a negative 4 and a positive 3. But remember back at the beginning of the notes when we talked about extraneous solutions and what that might do. All right, so in this situation, does one of these solutions actually work out to be an extraneous solution? We can try that. We can put them in and see what that would work out to be. And if we plug in a 3 or a negative 4, you have to test those out and see if one of these is extraneous. What I'm going to ask you to do, if you've watched this whole video, is you tell me in class if one of these solutions, negative 4 or 3, is extraneous. Do that. All right, let's move on to number 6. By the way, example problem number 7 right there, take a look at it. That's the one that we will be solving in class. Write that down. That's example problem number 7. We'll solve it in class. All right, don't forget. Now we'll do example problem number 6. Okay, I'm going to go ahead and rewrite this. I'd like you to notice we have an exponent that's a fraction, a fractional exponent of 1/2. What does the fractional exponent of 1/2 actually mean? It means the square root. So let's rewrite this. 3 square root x plus 6 equals 9. Now we go through and do all the normal steps just as we've already done. We can divide both sides by 3 because we're trying to isolate the radical. These guys cross out. Square root x plus 6 equals 3. Now we need to get rid of the square root by taking the square of both sides. Cross out, cross out. X plus 6 drops straight down. 3 squared is 9. All right, last step, minus 6. They cross out, minus 6. X equals 3. There you go. All right, last one was taken care of, and I know I didn't write this up here, but I'm going to go ahead and ask you guys a random question. If you could, if you are a fan of Parks and Rec, I am, I would like you to tell me in class what your favorite quote is from Parks and Rec. All right, that's going to cover us for this video for Algebra 2 notes. Zoom out, there's 5 and 6, everything you had to see there. Let's go ahead and scroll up. 1 through 4, all the example problems for that. All right, you guys got this. Work hard, ask questions in class, come prepared, and I will see you guys in the next